so far we have used the assumptions for testing the hypothesis in the simple regression analysis in the chapter 7 and multiple regression in chapter 8 without really going into how to verify whether those assumptions are valid or not. So this is where we're going to do that. We're going to check the assumptions, then see whether they are valid or not. But what remedial action we can take if they are not valid, so that will be in the next chapter. So here we are only looking at whether the assumptions are valid or not. So let's start with the first one, which is really what is called the model assumption, which means that the mean of y given x is this function, okay, the regression equation. Okay, the mean of y is a linear function. So that's what we are saying. So how do we test whether this assumption is true or not? So we can look at a couple of plots here, and these are verifying these assumptions are not like plugging in a formula and then outcomes verified or not verified. So it's not like that. It is more judgmental. You have to look at the graphs and then see whether those graphs the plots look reasonable or not. So there's a lot of judgment involved here. So what one person may end up with may not be agreeable for somebody. So you need to be a little bit flexible and make sure that the conclusions that you arrive with respect to validity of these assumptions is defensible. You should be able to stand up and then say why you think that these assumptions are valid or not valid. So to test the first assumption, we can look at a couple of residual plots. One is the plot of the residuals. Residuals is the error term, okay, on the y-axis, and y hat, the fitted value. Fitted values are the y hat values. So the y hat value, so remember y hat is a linear combination of the x's. So if you plot y hat on the x-axis, that is like somehow combining all the x values and plotting those combined x values on the x-axis and residuals on the y-axis. That's one plot. Or you can look at the x's individually. You can make a plot of the residuals on the y-axis and the x value for the first x, then x value for the second x, and x value for the third x, and so on. But that ends up, having, suppose if you have like 15 variables and you have 15 different plots, but sometimes it's important to look at individually, but collectively, if you look at the plot of the residuals with the fitted values, that will give you a fairly good idea. Okay. Now, what are you looking for if the residuals? Remember, residuals are just random error values. So if the plot gives you the points in the plot, they're all randomly distributed, and you cannot make out any pattern, then that's a good thing because the error values are completely random. That means the model that we have assumed is valid. But on the other hand, if there is a pattern that you can see, suppose if the error values are in a kind of a band that is non-linear like that, or it starts low and goes up gradually. So if you see some kind of a pattern like that, and that's bad because the error terms, which error terms is what? Error terms is residuals. We are not going to use that in any of our analysis. But it looks like the residuals that we are throwing out has some pattern. So there is some baby in that bath water. So that's not good. So if there is a pattern in the residual plot, then that means the assumption is not correct. There is some modification that needs to be done. So usually it is because you omitted some variables that are important that should be included in the model, or if it is a non-linearity that you see in the residuals, then maybe a non-linear term should be added into the regression analysis, and we will look at how to do that in the next chapter. So let's look at this assumption, the first assumption in Excel. So the first assumption, R1, is the expected value of y is a linear function of the explanatory variables or the x variables. So we're going to look at the plot of the residuals and the fitted value. So we've already generated the output here. Okay, so here is the residuals, and the predicted y, that's your fitted value. So remember, predicted y is the fitted value. Okay, so what we're going to do is, this is your x-axis and that's going to be your y-axis. So if you have x-axis first and then the y-axis value, you can highlight those two at the same time and then insert a scatter plot. So we want a scatter plot here. Okay, we'll select that and we'll move this to the top. Okay, so now we look at this plot. So this is your standardized regular residuals and fitted value. So let's add the x-axis title. So this is fitted value of y. And this is our residual. Okay, and you can see that you don't see any non-linear pattern. It looks like reasonably random. So we can say that the plot of residuals is random and free of non-linear pattern, and therefore our R1 assumption is reasonable. Okay, now let's look at the next set of assumptions. Okay, let's go to the Word document.